Alright, this video is going to be a little bit different because I'm going to be taking the unit test of the similarity unit in the geometry course in Khan Academy. The dash triangle and triangle OPQ are similar. Okay, and since MN is parallel to PQ, these are congruent because the vertical angles are congruent. This is congruent to this because alternate interior angles are congruent. This is congruent to this for the same reason. So triangle NMO is similar to triangle QPO. NMO QPO. NMO. So OPQ. Q. Where do you get Q from? OP. Oh, I wrote it wrong. QPO. No, I didn't write it wrong. So OPQ. So OP corresponds to OM. OPOM. PQ corresponds to MN. And QO corresponds to NO. So this is correct. Below is the proof of the Pythagorean theorem, blah blah. OMN is congruent to PMO. OMN is congruent to OMN. PMO. They're congruent. OMN, PM. Oh, I'm reading wrong. OMN, PM. Oh, that's reflexive. I think I read it wrong. So they're congruent. They're similar by the angle because we have two angles that are congruent. A over X. So MO over MP. MO over MP is the same thing as, let's see, B over A. That is ON over OM. ON over OM. That does not look like that is correct. So A is OM. I need to write this down. A is OM. X is MP. So OM over MP. Let's see. Okay, so NO over OP equal, and the last but not least, MN MO. So NOOP is B over the dashed line, and MNMO is C over A. Okay, similar, so chop map one figure onto the other using reflection and dilation. It's not possible to map blah blah using a sequence of ridge transformations and dilation. So yeah, she's correct, or he's correct, because that's the exact definition. Okay, so if two triangles are similar, their angles are equal. So we can find this angle, which is 180 minus 90 plus 32, which is, let me enter in the calculator. 180 minus 90 plus 32, that's 58. So we can check the other triangles here. We won't see a 118, so it's not A. We see a 58 here and a 90 here. So this triangle is similar to that triangle by the AA similarity theorem. So it's B. This is just basic stuff that you should already know. Just cross and multiply. 3x plus 1 equals 9x minus 6. Subtract 3x from both sides. Equals 1 plus 6 on both sides. Divide 6. X is 7 over 6. In the diagram below, DR is perpendicular to OP. So you can say this is congruent to this because complements of congruent angles are congruent. So we need to find the area of DUO. So we need to find this. Now we can use the geometric mean, but I'll use the standard way of doing this. So we can say which two triangles are congruent here. We can say so okay, so a triangle UMD is similar to triangle APD because of the AA similarity. So we know we're trying to find what MU is. So MU over AP, which is 4.5, and we know what MD is. That's 10. PD 3.75. So 3.75. So 4.5 times 10 divided by 3.75 is 12. So MU is 12. MU is 12. And you find the area of triangle DUO. So 14 times 12, half of that is, so 14 times 12 is 168, and take the half of that, you get 84. So the area of triangle DUO is 84, but I'll show you how to do it with the geometric mean. So to find this, since it's you can't actually use the geometric mean here because this is not a right triangle actually. So I'll just say it's 84. What's the length of CD? This angle bisector theorem. 4.9 over 2.6 equals 6.5 over CD. It states that this over this is the same thing as this over this. So I'll just enter all of this in the calculator. So 2.6 times 6.5 over 4.9 is approximately 3.4. Which triangles are similar to triangle ABC? So two triangles are similar if all of their corresponding sides are proportional. So let's see. Let's check this triangle. So 11, the longest side over 1.4, the second longest side 8 over the second longest side 1, and the shortest side 5 over 0.9, 5 over 0.9. Yeah, it's not A because these two are not. The proportions are not the same. Let's see for B. The long side 21 over the long side 1.4. The second long side 15 over the next long side 1. And then the next long side 13.5 over 0.9. Is this so? Let's see. 21 over 1.4. Yes, the B is. They all have a proportion of 15. Okay, so two triangles are similar if all of their corresponding angles are the same or congruent. So we can find out that angle with 180 minus 39 plus 37. So we enter this in the calculator, and we get 104. So we don't see 114 anywhere over here, so it's not A. And we go 114. I don't see any 114 in the solution I got, so it's neither. Alright, that's the unit test for similarity.